Okay, so I'm here to talk about the strategic plan, but before I do that, I want to extend what Anne Bosgaard mentioned in her very first slide when she showed Tycho Brahe and mentioned that Tycho was probably the recipient of the first federal grant for observing. I wanted to show you the observing proposal. This is from a wonderful rare book collection from a friend of the observatory in which it's outlining what he could do with his astronomical instruments if provided space to do it. By my hand, Tycho Brahe, 1581. So I thought you'd like that. All right, so Keck 25, the Science Strategic Plan. Why did we pick 2035? For many, many reasons, and you can read most of the motivation in the plan itself, but it's largely to say, let's future cast after a period of time where we've successfully renewed the least, after a period of time where JWST has gone through its prime mission, Hubble has ended, various other things have started up. Really future casting beyond sort of the 5-year time horizon for a variety of things. I won't have the ability in 12 minutes, particularly with the way I prattle on, to go through all of the plan, but I wanted to mention that we're celebrating the 30th anniversary of Keck, and Keck has been saving the world for 30 years. If you remember the wonderful 1996 film, Independence Day, the president is briefed on the alien mothership, and if you zoom in very carefully, you see that it is a 10-meter Keck image target acquisition at 0700 hours. Okay. Before I launch into the plan, I want to talk about sort of the scientific foundations which motivate the plan. And not surprisingly, the scientific motivations very equally match what the decadal had in mind, right? Talking about exoplanets, comparative exoplanetology, looking for the pale blue dots, but also the green, red, and brown ones out there, the transient universe, and the interplay between galaxies and their gaseous surroundings, and the formation of galaxies, the evolution of them, et cetera, et cetera. Not surprisingly, these have been Keck's strengths for 30 years. We helped define this. We'll hear about fast radio bursts after this. We did it with gamma ray bursts for a long time. And we heard Chuck talk about this, right? These are Keck's core strengths, and they're going to continue on for the next couple of decades. So those foundations are well in place. What's different is that this is working, right? And it's working fabulously well. And so how does the observatory work in this world along with this thing, right? And there will be at least one of these on the planet in about a decade's time. And so how do you work in that environment? And finally, Rich spoke to this yesterday. How do we modify not just, the science that we want to do, but the way that we do it when we move away from that view of Mauna Kea and move to this view of Mauna Kea with Mauna in the middle? All right, so let's also remember that something is coming. Right? The Habitable Worlds Observatory is coming. You can ask me about it later. I have lots of things to say about it. But how to prepare for an observatory which is effectively Keckish in space, and all the science and technology precursor work you need to do before that thing launches is a big part of what we should be thinking about. So the fundamental question that I wake up with every morning is, how does Keck not only remain competitive, but lead into the 20s and 30s and beyond, right? So the plan is here. Rich put this QR code up before. I'm going to have slides with way too many words on that I'm not going to read. You can read them in the plan. And I want to acknowledge all the people who were part of the plan, particularly the Science Strategic Plan in this talk. The Science Steering Committee was absolutely essential in this, right? Many, many meetings going into this. The AO Future Studies Group was essential to this. Our community of astronomers, many individuals, groups, all these things poured lots of information into this to distill into the plan, so I want to mahalo all of them. The thematic framing of the Science Strategic Plan is to leverage the current landscape that we're in, or the future landscape that we know, to grow scientific leadership, not cede it, and to harvest innovation, right? So this is where a lot of the words begin, but the thing here is that this is a rough timeline of things that are going to be happening over the next 15-ish years, right? US ELT is going to be turning on in the next part of the 2030s, but we've got little things like Rubin, right? Large changes in LIGO, large changes in radio surveys. JWST has launched, Euclid has launched, SphereX will be launching in a couple of years, Hubble will end, right? What? Probably. Roman's going to launch, and a variety of other things. The probe AO came out this morning, right? The landscape, both on the ground and space, is going to be radically different than it is today, right? So the power and grasp of those facilities is going to be very different than the power and grasp today, and our aperture superiority will wane, right? When you build a 39 meter, 39 is bigger than 10, even if you have 2 of them. And the interconnectedness of ground and space is going to become stronger, right? So the way that we need to respond to this is to radically increase our science efficiency. And that can mean many, many different things. But it's really important to do that, to not only be competitive, but exceed the capabilities of 30 meters in some cases. And so how do we grow scientific leadership, right? Tom just mentioned GLAO. GLAO is going to be a critical part of that efficiency, right? If you can get to your target and do your science a factor of 3 to 10 faster than you could before, that's fantastic. And then pushing to visible AO so that you could be doing science that no 30 meter will do in its first or second generation is critically important. And we want to go wider, faster, deeper, and smarter, sort of Steve Jobsian push of how to think about these things. And use the fact that Mauna Kea is such a pristine site, particularly in the near ultraviolet and at other wavelengths, right? So growing scientific leadership, what does faster mean? Faster means you want to have always-on capabilities for the transient world. You want to be able to provide science-ready data almost instantaneously so that you can get that out to the world, sometimes for the 30 meters to chase after, right? And you want to maximize the efficiency of your operations, right? You shouldn't be spending as much time as we often do, either reconfiguring the system, reconfiguring the instrumentation, et cetera, right? What does wider mean? You want to be able to expand on our core essential competency of multi-object spectroscopy by a factor of 10 or more so that you can be doing significantly more on the sky with every second, right? You want to enable wide, ultra-deep imaging that leverages blue capabilities. You won't be able to do it because Mike will steal all the time. And you want to maximize coverage of those bluest wavelengths. Mauna Kea is a pristine site for this. We should be using that. Deeper, right? Develop and deploy seeing limit in instrumentation behind GLAO. LRES 2 is going to be coming along the lines, but MOSFIRE can be modified for GLAO as well. And you want to maximize throughput for new instrumentation. Upgrade existing instrumentation with higher throughput capabilities. Develop and deploy visible wavelength AO capabilities, and then be smarter, right? We want to have science-driven operations and change how we observe sometimes as the science demands. An example of this is this KPF cadence concept. An example of this is the twilight zone and how to expand on that thinking, right? And develop data platforms potentially in the cloud for when you have to deal with the data avalanche, right? And finally, I like the idea of deploying ecosystems of instrumentation, right? Which is wouldn't it be wonderful if I could take a really deep image on the sky, deploy a secondary, and then take spectra and a multi-object spectrograph of that image in the sky, and do the science that used to take 3 years, say in the KBSS program that Chuck talked about, and do it in a single night, right? That would be amazing. But also we should be thinking about the interplay between KPF, high spec, and scales as an exoplanet ecosystem of instrumentation, right? And we need to harvest innovation. We need to be thinking about the technologies and the tools that we're going to need to do this stuff. So we need to push new technologies forward and incorporate them faster. Shown on the right are these funny things called star bugs, fiber positioners that can actually move around in the focal plane, right? But these need to be developed and be proven to be robust in the environment at Keck before you incorporate them. So you have to invest in that, right? You've got to provide dedicated space for AO development so that the collisions that oftentimes occur between development work, which is essential to bring new things, and operations work, which is essential to do the science on that night, that those collisions are minimized. And we're going to have to partner with the ELTs and NASA in the ways that we already have, but the more robust ways sometimes, so that we can retire some of their risk, but in doing so, utilize those capabilities at Keck, right? What did we come up with as a portfolio of things? We have sort of large, medium, and small, although those things should have quotes around them because they blend the lines of what's large, medium, and small. And I don't have enough time to go through all of this, but the plan describes each of these elements. A couple of things that I do want to highlight is that in the AO frontier, it's essential that we get to work now on an adaptive secondary mirror, right? The GLAO and potentially the visible AO are going to depend upon it. So this is one of the key things that we have to be doing and make decisions about very soon so that we can advance those. We heard about the wonderful capabilities of LIGO yesterday. It's essential to move those forward. Phobos is the multi-object spectrograph 2000 fibers on the star bugs that can move around, right? Ground layer adaptive optics for LRES and MOSFire, although for LRES it'd be LRES2, but modifying MOSFire. The wide field imager, and then moving on into things like visible AO and all those capabilities on Keck 1. In the medium class, high spec, we're already working on bringing high spec to Keck. The Instrumentation Development Fund, this is basically how you do the risk retirement for the instruments that you want to build and bring them up to PDR level, bring them up to a level of fidelity and of design to understand the risks, the true cost of the instrument, the schedule, how long it's going to take to do those things. LRES 2, Electric Boogaloo, this will be the update to LRES that we need. LRES is 30 years old, and we need to maintain this core capability, ideally behind GLAO, right? And a visible AO imager, an AO development fund, which is basically the mirror twin to the instrument development fund for AO development, and a variety of other things, including a second fiber feed for KPF so we can get that scheduling done easier and get those exoplanets faster. I want it all now. If you're old enough to remember this version of Willy Wonka and the Chocolate Factory, congratulations. You can't have it now, right? Even in the most optimistic scenario, one of the ones that I put up here, right, and you don't have to worry about the color codings, you're not going to be able to have this now. So the question becomes, now that we have the plan, how do you implement it? How do you decide which things to work on first? How do you decide to resource the things that need a lot of technology development before you want to spend real money, et cetera? And so, we have to map out how we're going to do this. It's completely dependent upon resources. If we had infinite money, we could do lots of things. We don't have infinite money, so we're going to do less than lots of things. But I want to underscore that the initial investments in bringing these capabilities here, the concept design and the preliminary design, are absolutely critical to the success of all this stuff. And if I wanted to do everything in the plan, that's $30 million over the next 10 years, just to do the early parts of it. And the total cost of the portfolio is over $400 million. So, get out your checkbooks, right? What are my thoughts on this? This is my sort of closing thoughts on all this. First of all, it's a really ambitious plan, and that's a good thing. If we had put out a plan that says, oh, we want to just keep doing what we're doing and maybe not change too much and, rest on the things that we know very well, I don't think that brings us forward to a place where we're still one of the premier observatories on the planet when there's 30+ meters out there, right? We can't do everything in this plan, or at least not all at once. And so this requires a lot of careful thinking now on how to implement it. And we are going to have to turn other things off. Whether or not this means other instruments or other science capabilities, that's to be decided. And I've got a slide advertising a discussion around that for the end of the day. But no, really, we mean it this time. We're going to have to turn some of these instruments off, and that requires decision making. And early stage investment is essential. We really must invest in bringing many of these things to a level of fidelity so that we know what the plan really costs. Keck will do things no other telescope on or off the planet can do now or in the next 20 years. So let's get started. And my final thought is this. We don't actually know what the key science of 2035 will be. I have proof of this. Well, Shelley does, but she's not telling us. Right? I have proof of this. This is the National Academy's study that predicted what they would use a large telescope in space for from 1969. Exoplanets, dark matter, dark energy, any of the things we've been hearing about over the last few days did not appear in this thing. And yet they were planning in advance for a telescope that would launch in 1990. So what we do and how we implement this plan has to be resilient against the science we don't know yet exists. So we have to be powerful and flexible. This is an advertisement for a really important discussion I hope you stick around for this afternoon. This is the beginning of the discussion of what do we turn off. This is your telescope, not mine. This is your telescope. You have to be a part of this discussion to decide where we're going next with this. So with that, thanks.